Alright, this video is a follow-up to a sequences video, and it's going to talk about what's called a series. A series, as is denoted at the bottom of the screen here, if you want to evaluate a series, the basic idea is we need to add up the terms of a sequence. So you'll notice at the bottom again we have this sort of interesting looking symbol. This is what's called sigma. It's a Greek letter, sigma. And what it means is to add up. And so what we're going to do is take I equals 1, and notice I is in our formula here, 3I minus 1. But if I were equal to 1, we would plug in 1, and all the way up to 5. And as you notice off to the right here, that means terms a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. And we are going to add them all up. So notice at the top of the screen, I've got that same sequence, right? The sequence is talking about just finding the individual terms. Again, the series means we will add them up afterwards. So let's find all the terms of the sequence. If n were 1, we would plug 1 in, or sorry, if I were 1, a sub I here. If I were 1, we would plug 1 in. So we're going to say 3 times 1 minus 1. 3 times 1 minus 1, which is 3 minus 1 is 2. And so a sub 1 would have been equal to 2. A sub 2, again, we're going to take that 2 and plug it in. So 3 times 2 is 6, minus 1 would be 5. And do the same thing for a sub 3, 4, and 5. So plug in 3 is 9, minus 1 is 8. 4 times 3 is 12, minus 1 is 11. And 5 times 3 would be 15. Again, minus 1 would be 14. And I'm going to go down to the bottom again then, if we're finding the series, again, of terms 1 to 5. The lower limit being 1, the upper limit being 5. Start counting from 1, stop counting at term a sub 5. Well, we're going to plug in the numbers then. Well, 1 was equal to 2, a sub 2 was 5, a sub 3 was 8 then, a sub 4 was 11, and a sub 5 is 14. And then finally, don't forget, that means we now need to add those up. So that makes 7 is 15, 15 plus 11 would be 26, and 26 plus 14 would have been 40. And our overall sum then, as it's often called, a summation, or the series from term 1 to 5 for 3i minus 1, would be equal to 40. Again, we're not going to get the individual terms. We're looking to find the entire sum all added together. So, take a second and try calculating the sum up top here. Again, we're going to go from terms 1 to 4, and your summation this time just has 3 terms. Note the parentheses. They're surrounding all 3 terms, which means all 3 terms are part of each of those individual steps, or parts of the sequence, terms, that are going to be added together. But again, go ahead and pause the video now, and then I will reveal underneath the blue boxes here some of the answers. And I will also show you that there's actually a shortcut. There's quite a few shortcuts actually for finding series, and we'll kind of uncover a few of those as well. But again, pause the video now and take a shot at finding the answer. Okay, well, on the screen here you can see I just took 1 and plugged it in for both of the I values. So 1 squared plus 2 times 1 minus 3, and that's all in blue here. Then I plugged 2 in for the red, 3 in is the purple, and 4 in would be the green. So that's terms 1, 2, 3, and 4. Calculated each of those numbers, so 0, 5, 12, and 21, and then add the 4 of them up, and you should end up with 38. Now, I mentioned that there are a whole lot of shortcuts as well. And one of the shortcuts basically has to deal with the fact that really we just found 3 terms for each term of our sequence. But if they're all just added and subtracted, really that's just a whole bunch of addition. We could add and subtract them in a different order as well, as long as we're careful with our negatives. So one way to think of a summation, if we're really just adding up 3 terms, but then finding another step where adding up 3 terms, is to sort of reorganize our terms. What if we found the summation of just the first term, since they're all added together really anyway, our 1 squared and our 2 squared, 3 squared, and 4 squared. And then we could also separate out our 2i. But hey, since each of those middle terms has a 2 in front of it, we could also factor out that 2. Or basically when we're looking at it, we could add up our squared terms first, we could add up our I terms first, 1, 2, 3, and 4. But if you really think about it, each of those terms had a 2 in front of it. So we're essentially factoring out that 2. And then finally, all of the remaining terms are minus 3, minus 3, minus 3, minus 3. If there's no variable in here, well, then plugging in 1 or 2 or 3 or 4 just keeps getting us a negative 3 every time. Because that negative out in front here. We're subtracting 3 just 4 times over. So why not just say negative 3 times 4? Really, those 3's are going to make a negative 12 anyway. So now we can do our squared terms first, then do our middle term times 2, and then finally do our constant terms. And we'll still end up getting 38. Again, those properties kind of illustrated at the bottom basically say, in the first part, if you have two things added together, we can separate it into two summations. If you have a number that's a multiple inside, so 3 times I can separate it or sort of factor out that 3. And if you have a constant term, well then however many terms you have from 1 to n, well that means there are n number of terms, and I can really, instead of adding up 3 over and over and over again, I can just take 3 times n, because that's how many 3's are going to be added together anyway. So kind of a few helpful shortcuts. So let's go to the next screen here and try employing a few of those shortcuts. So possibly the factoring in the first term here, or maybe the factoring in the second one. See if you can't find the answers to these two sequences or series, and then I'll show you a couple more shortcuts as well. Okay, so let's take a look at what we've got, and then I'll point out those formulas at the bottom, and we'll see if we can take advantage of those, because I hate that second summation. It's got a whole lot of terms in it. I don't really want to find 15 terms. So I hope there's maybe a nice shortcut, and there really is, one that we can take advantage of. So in the first sequence, though, or first series, I should say, let's take that 3, and we're going to factor it out in front, because again, every term is just going to be multiplied by 3. We may as well just do that one time at the very end, sort of factor out the 3, add up all the parts, and then do the multiplying. So I squared would essentially be 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared, because we're just doing terms 1 to 5. And if you multiply all those out, add them all up, and then multiply by 3, you will end up getting 165. Now, at the bottom you'll notice there's 3 different shortcuts that we can kind of take advantage of. The first one of which we've already really looked at. If you have a constant term inside of your summation, such as a 1, well basically if I have n terms, that means I'm just adding 1 to itself n times. So really, n times 1 will be n. If I have I to the first power, there's another nice shortcut, and it's basically that you can take the number of terms again, assuming you're starting at 1. Each of these formulas, notice, has had 1 already in the formula. So if I'm taking n terms from 1 to n of just the constants, or just, sorry, the integers, essentially, 1 and 2 and 3 and 4, there's another nice shortcut that says n times n plus 1 over 2. So, up here at the top, you'll notice I took advantage of the next formula over. There's also another power formula that says that I squared, if that's all I have in my summation, and my summation starts from 1, then if I have n terms, I can use this formula over here. So what I did was said, well, hey, I have 5 terms. And this is really just the summation of I squareds, just like the formula says at the bottom. So, in that case, I'm just going to plug 5 in. 5 plus 1 would be 6, and 5 times 2 plus 1 would have been 11. 5 times 6 times 11, all divided by 6 here. Note 6 is in the formula. Cancel the 6's, and 55 times 3 also comes out to 165. Now, we didn't really need it. Notice it was just as fast to do it the other way around. With just 5 terms, you can kind of do that one either way. However, on the right side, like we said, we don't really want to find 15 terms. So as long as this is just the sum of I to the first, we can use that middle formula from down below here. So I'm going to say, pull out the 4. Notice we already did that from I. Also notice that plus 10, but hey, there's no parentheses here. which means really this is the summation of 4i, and in the end 10 is only added in there one time. Otherwise I would have separated my summation, and we could use that 10 over here in this constant formula. I would have just taken 10 times 15, essentially, and gotten 150. But since it's not in the summation, it's only in there one time. So let's use our formula from the middle down here. We have 15 terms, so that's going to be n is 15 times 15 plus 1, so 16, divided by, note the 2 in the formula, and then we've got this plus 10 up here on the outside. So we can say that's 4 times. So I'm going to grab my trusty calculator, type in 15 times 16, and divide by 2, and I get 120. And then don't forget our plus 10, which just means that 4 times 120 would be 480, plus 10 is 490, and we've quickly got our answer without having to do 15 different steps in our series. So I hope that helps you kind of understand series a little bit. Oops, so I thought I had another screen there. And hopefully that will help you out. And if you have any questions, make sure you talk to your teacher. Otherwise, good luck and happy adding.